So the last topic of this video lecture is Coulomb's law, and Coulomb's law basically it gives the relationship between the force and charge. And if there are two bodies whose charge is Q1 and Q2, and suppose they are r distance apart like this, then Coulomb's has given the relationship according to the Coulomb's law. The force between these two charged bodies Fe is directly proportional to the product of the charge, that is Q1 into Q2, and this electrostatic force is inversely proportional to the square of the distance between these two charges. So if we combine both the thing, that is Fe is proportional to Q1 into Q2 and Fe is proportional to 1 upon r square. If we combine both the things, then Fa, that is the electrostatic force between the two charges having charge Q1 and Q2, and the distance between the charges r is proportional to Q1 Q2 upon r square. And if this is the proportional thing, if we remove this proportionality sign, then this expression becomes Fe, that is the force between electrostatic force between the two charges, is equal to K into Q1 Q2 upon r square, which is given by this expression. And here K is the Coulomb's constant. K is the Coulomb's constant, and its value depend upon the medium between these two charges and also the system of unit used. The value of K, that is Coulomb constant, depend on the two things. First of all, the system of unit used. For SI unit it is different, for Cgs unit it is different, and the nature of the medium in which charge are placed. For different medium, the value of K is different. So let's see what is the value of K in SI unit. So Coulomb law in SI unit we can write like this, and in SI unit the value of K is equal to 1 upon 4 pi epsilon, and which is equal to 1 upon 4 pi epsilon naught epsilon r, which is the relative permittivity of the medium or dielectric constant of the medium. It can be also written as epsilon r. It can also be written as the capital K. This is a small k and this is the capital K. Capital K is dielectric constant, small k is the Coulomb's constant, and that Coulomb's constant is equal to 1 upon 4 pi epsilon, and which is equal to 1 upon 4 pi epsilon naught epsilon r, where epsilon naught is the absolute permittivity of the free space, and its value is given by 8.85 into 10 to the power minus 12, and it remains constant whatever the medium we are using, but it remains always 8.85 into 10 to the power minus 12. And ER, that is the epsilon r, is the relative permittivity of the medium or dielectric constant of the medium. So in any medium, the force between the two charges is given by Fm is equal to 1 upon 4 pi epsilon naught epsilon r into Q1 Q2 by r square, because K, the value of K in SI unit is this one, 1 upon 4 pi epsilon naught epsilon r into Q1 Q2 upon r square. But for air, in case of air, the relative permittivity epsilon r is equal to 1. So for air, this expression become Fa, that is the force between the two charge in air, A stand for air, is equal to 1 upon 4. If we put Er is equal to 1 over here, then we will see the expression has changed. Fa, that is the force in air between the two charges, is given by 1 upon 4 pi epsilon naught q1 q2 upon r square. So this is the expression of force, electrostatic force between the two charges when they are placed in air, and in any other medium the expression is given by Fm is equal to 1 upon 4 pi epsilon naught epsilon r into q1 q2 upon r square. So now Coulomb's law in Cgs unit. In Cgs unit, the value of small k is equal to 1 upon k, and if we put over here, so Fm become 1 upon Fm. Earlier we have seen that Fm is equal to, in the earlier expression, that is equal to 1 upon 4 pi epsilon naught epsilon r q1 q2 upon r square. Now this is the expression in case of SI unit. In Cgs unit, the Coulomb's constant is replaced by 1 upon k. So in any medium, the force between the two charge in any medium is given by 1 upon k q1 q2 upon r square. K is it is a capital K, and it is called dielectric constant. And in case for air or vacuum, so the value of k is equal to 1. So if we put k is equal to 1 over here, then the force between the two charge in air is given by q1 q2 upon r square, as given by this expression. You can see here Fa is equal to q1 q2 by r square. So the value of small k, that is the value of a small k, which is Coulomb's constant, depend upon the unit used. For SI unit it is different, for Cgs unit it is different.